3, we're going to find the inverses and then go ahead and label those domains because they might be restricted, right? So we're going to look at those x's that don't work. Okay, but first we need to find the inverse. So first we're going to switch f of x to y. So this would be y equals x squared plus 2x plus 4. And then we're going to switch or swap our y's and x's. So this will become x equals y squared plus 2y plus 4. And then we're going to solve for y. And this is a little bit tricky because I have a y squared in there, right? So I want to factor this, but factors of 4, what times what is 4 but adds to 2? Well, there's nothing there, right? So I want to go ahead and move over that 4. Leave a blank there. So what I want to do is complete the square because I know I can get rid of squares by square rooting, right? But the only way I can do that is if I have the same thing times itself, right? So I really want a perfect square trinomial. So I take my b and I divide it by 2, and then I square it. So I'm going to take that 1, and I'm going to add 1 to both sides. So I get x minus 3 is equal to y squared plus 2y plus 1. Because now when I factor this, I get y plus 1 times y plus 1, right? Because 1 times 1 is 1, and 1 plus 1 is 2. So I could rewrite that as 1 plus 1 quantity squared, x minus 3. And now I can get rid of that squared by square rooting both sides. So we have square root of x minus 3 is equal to y plus 1, right? Because these cancel out. Now I can go ahead and solve for y by subtracting 1. And I can't take negative 3 minus 1 because that negative 3 is under the square root with that x. So it is, and whenever I take the square root, I do have plus or minus. So I do have plus or minus negative 1 plus or minus the square root of x minus 3 because I'm subtracting 1. So I can just put that in front like that, equals y. And very last step is to take y and switch it to f inverse of x. So f inverse of x is equal to negative 1 plus or minus the square root of x minus 3. Well, restrictions on our domain is what can I not plug in for x, right? Those restrictions. Well, we know when we take a square root, well, we can't take square roots of negatives, right? So once we go below 0 on a number line, we cannot have those square roots, right? So if we set this equal to 0, it's fine having 0, right, as 3, because I know the square root of 0 is 0. So if I plug in 3, I get an answer of 0, which is good. But if I plug in, say, negative 4, or just 4, isn't that going to be, or something, sorry, less than 3? So if I plug in like 2, isn't it 2 minus 3, negative 1? So anything less than 3, or equal, just less than 3. Just less than 3 is going to give me negative numbers, right? So negative 2, 1, 0, negative 1, those are all going to give me square roots of negatives. So there's my domain restriction, anything less than 3. So that is my domain. So here I have my inverse equation function, and then here I have that domain, that restricted domain.